All right, so we're moving into a new unit. This one's all about rational expressions. Okay, so we're going to learn what those are, and then we're going to learn how to simplify them. Okay. So let's talk about what they are first. Good morning. So what is a rational expression? It's basically when you take two polynomials and you make a fraction out of them. So today's topic, guys, we're just basically going to be learning how to simplify these things today. Simplify rational expressions. So what it boils down to is reducing. So another word here in this case would be like when you're talking about fractions, to simplify them means to reduce them. But the way you typically are going to end up doing it is you're going to factor, and then you're going to cancel, which is the reducing step. So I'll show you a couple of examples like that. We all good? All right. So we'll just go ahead and jump into a couple of example problems here. Let's start with this. We'll start with monomials. So go ahead and write down that one. We'll call this example 1. So for this one, you guys are basically just going to reduce it like you normally would. So what can you find that goes into both 24 and 80? What's the biggest thing you guys can think of? 4? I agree. I know 4 goes into 24 6 times, and then 4 goes into 80 20 times. So we reduced by 4 there, right? But I don't think that's it, because we could still divide out by 2 now, right? So if you don't pick the biggest number, you just have to keep going until it gets all the way down. So it turns out, I guess the biggest number would have been 8, right? Yeah, so that's okay. I wasn't thinking of it either. So divide the top and bottom by 2. We're going to reduce again, and we get 3 over 10, right? Now that's for the coefficients there, but we also have these variables, right? How do we do that? Well, yeah, just A on the bottom, right? There's your final answer. Okay, now why? If you guys are wondering why that is, many of you guys probably already know that, but just in case somebody's unsure, we have 1A on the top and we have A squared on the bottom, and A squared is A times A, right? So we're dividing here. So what's A divided by A? It's 1, right? And so you're left with 1 over A there. All right, so in this case, if I have A over A squared, I'm left with 1 over A. In this case, the 1 gets multiplied with the 3, so you just leave it as 3. But there we go. The shortcut is to subtract the fraction, or the exponent. So 2 take away 1 is 1, right? And notice that wherever the bigger exponent was, that's where the leftovers will be. So if my bigger exponent was on top, the leftover A would have been on top. But if the bigger exponent was on the bottom, it would have been on the bottom. All right? How many of these I do? Let's do another one real quick just to walk through it. So what's the biggest thing that goes into 24 and 42? 8? No, yes, 8 doesn't work. 6? I think 6 is. 6 goes into 24. Right, reduce by 6, right? Reduce by 6. So that would be 4 over 7. And that's good. Now how about the A's? What's 3 take away 2? 1. So I'm going to have 1 A left, and where's it going to be left at? Top or bottom? On the top, because that's where the bigger one is, right? That's the answer.
That's it?
Yeah.
Are you sure?
Yeah, I mean we're gonna go more. I mean, but this is the first type of problem we're gonna get. But for our first example, this is what I want you guys to know. All right, so see, they're coming. All right, do this one real quick. I wonder if there's another one after this. Actually, let me give you 2 of them. Yeah, try both of those real quick. The steps that I gave you guys at the beginning of class today are really for most of the types of problems we're looking at. The first example we did, those steps don't really apply. It's just reduced like you normally would. But when you're talking about polynomials, right, more than one term on the top, more than one term on the bottom, our strategy is going to be the steps that you guys wrote down. Factor and cancel. Okay? So let's factor. We always start by looking for a GCF. So let's start with this one on the bottom. Is there a GCF?
This is a rational.
They're all rational expressions. But is there a GCF here on the bottom? What is it? So let's write that, 4v squared. And if I took out a 4v squared, what would be left on the inside? V plus 5. Can I factor this anymore? I probably won't make the factorings too challenging on this, because the focus is not really on the factoring this chapter, it's more on the rational expressions. So oftentimes it'll just be one thing like that, where you have to do one thing. So that one's factored. So now let's factor the top. Is there a GCF here? No. But it's 3 terms. How do you factor something with 3 terms? Use the box method. So let's do that. I'm going to work that out here real quick. When you have 3 terms, the first term goes in the top left, last term goes in the bottom right. We look for 2 numbers that multiply to make v squared. And we look for 2 numbers that multiply to make 45. Complete your box. Check to make sure these 2 add up to make the middle. I need it to be a negative 4. So that would happen if the 9 was negative, right? And so this thing here on the top has factored into v plus 5 and v minus 9. I'm going to rewrite it now a little bit cleaner. But we have completed step 1, which is to factor. Okay? So step 1 is to factor. It'll be simple factorings like either box method or difference of squares or GCF. It won't be any of the crazy stuff involving synthetic division or anything like that. Okay? Step 2, after you factor, is, what did I say to do after that? Cancel and reduce. So what can I cancel and reduce here? The v plus 5. That whole thing goes away. And so here's what I'm left with. V minus 9 over 4v squared. That's good? All right. Okay? So same thing for you guys. I'm trying to make them look the same as much as possible to kind of jumpstart your your engines on the factoring. The bottom's a GCF. Okay, so you need to start by taking out GCF. The top is a box method. So go ahead and factor those and cancel out what they have in common. What does the top factor into?
7 and -7.
I think they're both plus, actually. Let's see that one, sorry. Maya, what'd you get for the bottom? Okay, and then, well, guess I'll give it to nope, so Ollie's not here today. Malak, what's next, my dear? There you go. Okay, so that's the basic idea. If you can do that, then you're going to be pretty well set for the rest of the day, because the other types of examples we're going to look at, the other things we would add are very basic and simple. If you can just factor and cancel, you're well on your way. But there it is. Any questions about that? All right. Let's move on to another one. We're talking about multiplication. Multiplication. So go ahead and write down this one. It's example 3 here. Okay, so whether or not you write this part over here, it's not, I don't think it's really all that big of a deal. But so the rule is that when you're multiplying fractions, how do you multiply fractions, you guys? Top by top, bottom by bottom, right? And then you end up with just one big fraction, right? So basically, when you see this little dot in the middle, what you can do is you can just think of this as one giant fraction, because that's all it's going to become anyway, right? You're multiplying top times top, bottom times bottom. And therefore, it doesn't really matter if a like term is in the top on this fraction that matches a like term on the bottom in this fraction. They can cross-reduce, because really they're going to come together and just become one fraction anyway, right? So that's it. So the only difference with multiplication is that you have more pieces, but the process is the same. You still factor and cancel. Okay, so let's take a look at this. Can anything up here be factored? Very good. That is a difference of squares, so we want to do that, okay? So what is the difference of squares there factor into? Okay. Now, what can cross off here? The x plus 1 can take this x plus 1. Now, these ones look awfully similar, don't they? But they're not the same. So let me show you guys a little trick. This little trick I would write down, okay? Well, don't write this yet, but just pay attention. What is 5 take away 3? And what is 3 take away 5? They're the same number, just opposite signs, right? And so what happens if you divide the same number but with opposite signs? You get a -1. So here's what we're going to do, okay? This is what I would write if I were you. If you ever have a minus b over b minus a, you can cross those off, but it makes a -1. So don't forget to put a negative, okay? So I'm going to do that here. I'm going to say that cancels this, but it puts a negative in front. The whole thing. Because you're dividing something that's essentially the same thing, it's just their opposite signs. And when you divide a number by itself that's opposite signs, you get a -1 as a result. So, what am I left with then here? You have an x minus 1 with a negative. So this is a fine answer. That's probably how they would leave it, but technically you could distribute that negative in. But I'm just going to leave it like that, okay? So, two things that we learned here, right? Multiplying is basically the same thing as what we just did, factor cancel, so nothing new there. but we'll say that's our first thing we learned. Second thing we learned was you can cancel a minus b over b minus a, but it will create a negative. Now remember, that only applies to subtraction. So if you had this, that would not equal -1. That would equal a +1 because you're dividing something by itself. B plus A is the same thing as A plus B, just like 3 plus 5 is the same as 5 plus 3, right? So it only applies to subtraction. All right, let's have you guys try one here. See what you can do. All right, so we're going to treat this just like one giant fraction then, right? But we do have some factoring that we need to attend to. So, Kalani, what does this thing factor into? Good, that's our difference of squares there. Andrew, did you get this one factored? Elijah, what did you get for this one?
N minus 5 and n plus 3.
That is correct. Okay. And then after that, we just start canceling stuff, right? Like this n minus 3 cancels that n minus 3. Now you can't cross off this n plus 3 because there's not another one down here. You can only take one on the top for one on the bottom. That's just how reducing works, right? But the n minus 5 can cross off with the 5 minus n so long as I put a negative in the front, okay? And so my final answer is going to be negative n minus 3 times n plus 3. Okay? Yeah. Probably did it in Algebra 1. Definitely did it in Algebra 2. But we have to review because it's not like you do it every day, right? All right. We'll get to some pre-calculus stuff later with this. I promise. I know you're chomping at the bit. You're excited for it. All right, one more type of problem. Let's call this example 3. Oh, is it?
Yeah.
Example 4. Thank you, Mr. Elijah. First little detail I want to throw on here is if you ever have, you guys know something different here, right? This one's not a fraction. That's really easy to fix. Just put it over 1. Now it is, okay? But let's talk about division. How do you do division? You might want to write this one. How do you do division? Huh? Not quite. Yeah. Some teachers call it same change flip or keep change flip or something like that. So you keep the first fraction the same.
Second one is 3.
That's right. You keep that fraction the same here. You change this into multiplication, and then you flip this one over.
KFC.
Yep. It's KCF, which is like KFC.
Yeah.
And then it's a multiplication problem, so you just do it the same way we did before. So it's once again, it's really just the same thing. It's just that with division, you have this extra step in the beginning of keep, change, flip. Okay? So here we go. I'm going to keep this the same. I'm going to change that into multiplication. And I'm going to flip this over. After that, it's a multiplication problem. So we just do what we did last problem. We factor and cancel, right? So at the top here, what method do I use to factor that? Is it GCF box or difference of squares? It's a GCF. What goes into both of those? 3b, right? So if I divide both of those by 3b, I'd be left with b plus 9. The bottom doesn't factor. This one does, though. What's that one? GCF box or difference of squares?
No, good. Same thing.
It was almost. It's not a difference of squares because it's plus. Yeah, so it's another GCF. What goes into both of these? 9 and B. So that would leave B plus 4. Okay. So what cancels here? Good. So this is what I have left right now, right? We have 3B over 9B and B plus 4.
It's okay. We can only, we can also like 3B and 9B, right?
You're right. So that's our next thing. Remember the beginning of class today? The very first problems we did? The monomials? That's what we have here. So cover up that B plus 4 really quick. We have 3B over 9B, right? So first of all, those cancel out, right? And what's 3 over 9 reduced to? So sometimes you have monomials, especially when you do the GCF method, you'll have monomials that you'll need to reduce, just like we did at the beginning of class today. Okay, so we learned 2 things here on this one. With division, what's the first thing you do? Same change flip or keep change flip. And then the next thing that we learned was if you have something without a bottom, what do you do? Put it over 1. That's it. Okay? So, let you guys try one and that'll close us out for the day. See if you can take that one home. Okay. So you guys should have put that over 1 first. You keep that one the same. You change that to multiplication. And you flip this one over. You guys can go if you want. I'll see you guys tomorrow, okay? I will continue working out if you're interested. It's a GCF on the bottom there. Those cancel. There it is.
Yeah, pause it.
I didn't.